Right, moving on to question 11, an averages question. First one is the median. Well, the median is where you need to first of all order your list of data, and what we have here are the ages of 8 members of a team. So scan your list, you'll see the youngest age there, or the smallest number, is 21. I think I'll put a little dot under that so I know that I've used it. Next we're going to have 23, then there's 24, then we've got a 27, then 33, then 34, then 41, and finally 45. So the way that you find the median is it's the middle term in an ordered list, if there is a middle. Because we've got 8 members here, so we've got an even number of items of data, there won't be a middle, there will be a middle pair. That gives us 3 that side, 3 that side. So what we then do is find halfway between 27 and 33. If you add those two together, you're going to get 60. Half of 60 is 30. So the median age is 30. Find the range of the ages of the members of the team. Once they're in order, that's easy. It's the difference between the largest and the smallest value, which in this case will be 45 less 21, which is 24 years. The mean age is where you have to add them all up and divide by the number of numbers. So when we add all of these together, we get 23 plus 27 plus 45 plus 24 plus 33 plus 34 plus 21 plus 41, which comes to 248, and we divide that by 8 because there are 8 members in the team. So the mean age is 31 years. Okay, here's a little twist at the end of this question there. One evening a member of the team did not turn up. The mean age of those that were present was 29. What was the age of the member who did not turn up? Well, we know that if one person didn't turn up, the mean would be out of 7. And we don't know what the total would be, but we know that the mean of those that were there would be 29. So on that night, the total age of all the people is going to be, in order to get the question mark on its own, divide by 7 becomes multiply by 7. So we do 29 times 7, which is 203. So the total age that night was 203 years. When everybody was there, the total age was 248 years. So the person that was missing is going to be the difference between the total age on the night when there were 7 people there and the total age on the night when there were 8 people there. So age of missing person would be 248 less 203, which is 45. So it's the 45-year-old that didn't turn up. You explain that again? On the night when there were 8 people there, the total age was 248. And we got that by adding up all of those ages. The following night there were only 7 people there, and the mean was 29. So we know that whatever the total age was that night, when you divide it by 7, it comes to 29. So to work out what the total age was that night, you would sort of undo that equation by doing the opposite of dividing by 7, which is multiplying by 7. So on the second evening, the total age was 203. So to find out who was missing, you would do the age when there were 8 people there, the total age when there were 8 people there, which is 248, less the total age when there were 7 people there, which was 203. So the age of the missing person was 45. Okay, then we got a bit of algebra to do. So the first thing to do here is gather up the like terms. If you remember when we did this in class, what I told you was that the sign in front of each term is the sign that's connected to it. So if there's no sign there, it's a plus. So that there will be plus 4x. And we've got another, x term there, which is plus 6x. So we've got plus 4x plus 6x makes plus 10x. And then if we look at the other terms, they're just number terms. I got a plus 3 term, and I got take 7. So that means you're starting on your number line at plus 3, and you're going down 7, which means you'd end up at minus 4. So you could write that as plus 10x minus 4, or just 10x minus 4. Either way, that would be correct. And the second one of these, or second part of this question, is where we have to draw an equation on a graph, a formula on a graph. So what we're going to be drawing here is y equals 5x plus 1. And the first thing we have to do is fill in the gap on the table. And when we did these in class, what I suggested you do is first of all pick a value of x that you know the y value for, to make sure that you're going to use your calculator correctly. And what I also said was, when you're putting these into your calculator, if you look at the x there, if you turn the x, the two parts of the x around, it becomes brackets. So wherever you see an x, think of on your calculator brackets, and then you type it exactly as you see it. So if we're talking about minus 1, what we're going to type on our calculator is 5, and then instead of x, open bracket, and instead of the x we're going to put the value minus 1 there. Now that isn't take away 1, so it isn't that button on your calculator, the subtract button, it's the negative button which is there. So negative 1, close bracket, add 1. So what I've typed in there is exactly the way the formula looks, except wherever there's an x, tells us, oh, we need brackets there, and then put the x value inside. Press equals, and we get negative 4 out. That's what we got there. So I know that I'm using my calculator correctly. So for the value that I've got to work out, I'm going to do 5, open bracket, 1, close bracket, plus 1, which equals 6. Okay, so I've completed my table. Now I need to draw this graph. What we're given here are coordinate pairs. So when x is negative 1, y is negative 4. So the first point, x negative 1, y negative 4, mark it with a cross. When x is 0, y is 1. When x is 0, now we need to work out our scale here. This is going up from 0 to 4 in 10 squares. So 4 divided by 10 is 0.4. So each one of these little squares is 0.4. Or another way of looking at it, halfway between 0 and 4 is 2. So that's going to be 2. Halfway between 0 and 2 is going to be 1, which is going to be 2.5 squares. So the 1 is going to go there. When x is 1, y is 6. 6 is going to be there. And when x is 2, y is 11, and 11, there's 8, there's 10, it's going to be halfway again, which is there. This particular graph is going to be a straight line, so we draw our graph like that. Okay. The questions that we practiced in class with this tended to be curves, and the equation that we'd be working out the line for there would be squares. Okay, so you may want to go back to the topic section and have a go at some of those trickier ones. That's one of the more straightforward ones I've come across. Okay, number 13. The sum of 7 single-digit positive whole numbers is 17. 6 of the numbers are equal. What is the other number? So single-digit positive numbers are numbers like 7 or 5 or 3 or 2 or 4. More than one digit would be 12, 13 and so on. So if I've got 7 single-digit positive whole numbers together, they come to 17, but 6 of the numbers are the same. So what I would do here is I'd start with one number. Let's say 6 of them were the number 1. So we'd have 1, add 1, add 1, add 1, 1, 2, 3, 4, 5, 6, plus the other number is 17. So 6 plus something is 17. The something is going to be 17. Opposite of adding 6 is subtracting 6, which is 11. 11 isn't a single digit number. So the next one I'll try is 2, because we're not far off. So if I've got 2, add 2, add 2, add 2, add 2, 1, 2, 3, 4, 5, add 2, plus something, the answer is 17. 2, 4, 6, 8, 10, 12, plus something is 17. So the something is 17 take away 12, which is 5, which is a single digit number. So the numbers are 2, 6 of them, and 5. Okay, so with questions like that, just try, pick a number, see what happens. If it works, well done. If it doesn't, how can you use your answer to that to decide what to try next? Number 14. This gets us into the C grades. 5 identical rectangles fit together as shown. What is the total area which they cover? Well, we can see there that when they're end to end, with their longest sides going along, the two longest sides together come to 18. So this side must be 9, and this side must also be 9. 9 and 9 make 18. And we can also see that if they're standing upright like that, 3 of those equal sides must make 18, which means that each of those must be 6. Now what I need in order to work out its area is its height. If that's 18, in order to work out the area of a rectangle, I've got to do base times height. I need to know what distance is. And for this distance, we've got one of the narrower distances, which is 6, and one of the longer distances, which is 9. So in total, that's 15. So the area of this shape will be 15 times 18. Which is 270. And in this question, this is the one where they're telling you to write down the units of your answer. So if you don't, even if that's correct, you're going to lose a mark. We're measuring in centimeters, so the unit is centimeters, and because we're talking area, it's centimeters squared. So to get the 6 marks for that, you need not only to have the 270, but also centimeters squared after it. Question 15. Okay, so first of all we got a trickier equation there because it's got brackets. We've done lots of practice with brackets in class. What you need to remember is when you're removing brackets, you're multiplying whatever the term outside is by every term that's inside. So you can do 4 times 6x, which is 24x, and 4 times 7, which is 28, and the sign outside, there's nothing there, which means it's plus. Plus times a minus makes a minus. Remember, if when you're multiplying and dividing, if the signs you're multiplying are different, the answer is negative. If the signs you're multiplying are the same, the answer is positive. Now we need to solve the equation. We can't get at the multiply until we've dealt with the take 28. The opposite of taking 28 is adding 28. So if we add 28, it's gone from that side, but we have to add it to the other side as well. So we get 24x is 60. And then to get the x on its own, we have to deal with the 24. The 24 and the x are joined by a multiply. The opposite of multiply is divide. So instead of multiplying by 24, I need to divide by 24 instead. And you can just leave your answer like that. Part B is an inequality question, but you treat it in exactly the same way as the rules above. Except instead of having an equal sign in it, we're going to have this less than sign. So the first thing we're going to do is get rid of the take 7 by doing the opposite of taking 7, which is adding 7. If you add 7 to that side, it's gone, but we also then have to add it to that side. So we have 4x is less than 12. Now we have to deal with the 4. The 4 is joined to the x by a multiply. The opposite of multiplying by 4 is dividing by 4. So we do 12 dividing by 4, and 12 divided by 4 is 3. When we're multiplying algebraic expressions where the base, the bottom part of it is the same, so we've got m multiplied by m, then we can simplify the powers. Now what this means, m cubed means m times m times m. M to the 4 means m times m times m times m. What that then becomes is m times itself 1, 2, 3, 4, 5, 6, 7 times, which you write as m to the power of 7. So you can either do it long ways like that, or you may remember the rule that if you're multiplying them, you add their powers. So 3 add 4 is 7. Number 16. Number of beans in each of 200 packets were counted. The table below shows a summary of the results. So make sure when you're reading this table, in your mind, you're happy what information it's telling you. Okay, so they're counting the beans per packet, and this line here is telling you that 42 of the packets had between 39 and 57 beans in it. This row is telling you that 50 of the packets had between 58 and 76 beans in them, and so on. One of the packets is selected at random. What is the probability that it contains 20 to 38 beans? Well, from the table we can see that there were 30 packets containing 20 to 38 beans. Now, if it's a probability that we're writing, we have to write that out of the total number of packets that were counted. So there were 30 out of 200 packets. So that probability would be 30 out of 200. Probability of selecting 58 to 95 beans. Well, 58 to 76, there's 50. 77 to 95, there's 78. So if I'm interested in 58 to 95, then it's both of those sections there. So we're going to have 50 plus 78, which is 128, but again it's still out of the 200 packets that we were looking at. Part B, which is the modal group for the number of beans per packet? Well, the mode is the group that comes up more than any other, and the number of packets that's the most frequent there, with 78, is this group. So the answer to this question is 77 to 95. It's not 78. 78 tells you that group is the most popular. And then the second part of this, on the graph paper below, draw a grouped frequency polygon to show the distribution of the number of beans in a packet. Right, don't worry about the idea of a polygon yet. Let's just make sure our axis is happy. What we need to do is the frequency, the number of packets, is going to go up. So I need to go up from 0 up as far as 78. And what you want to try and do is make this fit your graph, as the whole graph, as nicely as possible. So if I go up in 10s, 10, 20, 30, 40, 50, that's no good, it won't fit. If I go up in 20s, 20, 40, 60, 80, 100, that would be better. So my vertical axis I'm going to go up 20, 40, 60, 80. And then my horizontal axis, I need to go from 20 up to 95. So if I go 20, 40, 60, 80, 100, that'll work. Now I need to write on my graph what those axes actually stand for. So the vertical one is the number of packets. And the horizontal one is the number of beans per packet. Now, a grouped frequency polygon, rather than drawing bars, what you do is you join the midpoints of the top of each bar together. But if you are worried that you'll never remember whether it's a group frequency polygon or a group frequency diagram, then if you do the bars and the line, you can't go wrong, because they won't penalize you for choosing the wrong one. Whereas if you just draw the bars, you'd end up losing marks on this question. So I'm going to start drawing the bars, and then we'll look at the polygon part of it afterwards. So the first bar that we've got to draw goes from 20 to 38. So 20, each one of these is going up in 2s, because you're going from 0 to 20 in 10 jumps. So 20 to 38, and we're going up as far as 30. So there's 30, there's 20, and 38 will be 1 in from 40. So that's the first bar that we're drawing. The next one then is going from 39 to 57, which takes you from there to 57, which is going to be there, and we're going up to 42. 42, remember, it's 2 squares in this direction, and it's 2 squares in this direction. So we're going to go, where are we going? 42. Okay, the next one is 58 to 76, and that's 50. So 76 is going to be 2 in, and we're going up to 50. So we continue this line to 50, and 76 is going to be 2 in there, like that. And then finally we go from 77 to 95, and that's going up to 78. So 78 is 1 square down from 80, and 95 will be, there's 90, so there's 95. So that is not a group frequency diagram. That is not a group frequency polygon. It is a grouped frequency diagram. The grouped frequency polygon would be if those bars weren't there, but at the height of 35, you went halfway between 20. I can't see that. Sorry. You go halfway, the midpoint between 20 and 38. Halfway between 20 and 38. If you add them together, you get 58, and half of 58 is 27. So half of 58 is 27, so you would plot 20, 2, 4, 6. It doesn't look halfway, does it? Hold on. I've gone brain dead all of a sudden. 29, sorry. So you put a cross on the halfway point, then you do the same. The next one would be 39 to 57. 39 add 57, 96 divided by 2 is 48. So there's 40, 2, 4, 6, 8. There's the halfway point. Then you go 58 to 76. Divided by 2, 67. There's 60, 2, 4, 6, 7. And finally 77 to 95, halfway is 86. 80, 2, 4, 6. Those are the midpoints, and then you join those midpoints together with a line. And that's the frequency polygon. So the bars don't have to be there. Okay? The red line does. Full marks. For those 3 marks, you need to get your axes right and get that red line right. But you may find that it's easier to put that red line in once you've drawn those columns in. Without the red line, you wouldn't get the marks just for the columns, because this is asking for a polygon. So if in doubt, do both and you'll get the marks. Question 7. As if you don't get confused enough with utility bills, here they've given you 2 different ones to compare. So this is a really evil question. Okay, let's take a look. Mrs. Ridgely is considering changing her electricity supplier from B-line utilities to domestic utilities. She uses 2,400 units each year. She has found the following information. So for B-line utilities, we've got a standing charge of 15.7 pence a day and a cost per unit of 11.51. And what I suggest you do is work in pounds. It's easier. Okay, so the standing charge is 15.7 pence per day. So cost of standing charge will be, for the year, because that's what we're going to compare, we know 2,400 units a year, so we can work out what the total annual bill will be for B-line utilities. 365 days times, and then 15 pence in pounds would be 0.15, so that will be 0.1507. Work out what that is, and that will give you it in pounds. So that's going to be £55 and 0, and the second pence is 5 or bigger, so that would round up to £55 and 1. So the standing charge for a year is £55 and 1. cost of the units per year will be 2,400 times, and this time if it was 11 pence you would write it as 0.11, so 11.51 pence would be 0.1151, and that equals 2,400 multiplied by 0.1151 equals £276.24. So annual bill with Beeline will be the £276.24 that the units cost, plus the cost of the standing charge, £55 and a penny. So £276.24 I've still got on my calculator. Add to that £55 and a penny, and we get £331.25 a year. Now we do the same thing again, but with domestic utilities. So the cost of the standing charge will be 365 days, but this time it's 15.82 pence a day, so that's going to be 0.1582, which is going to be £57 and 74 pence. The cost of the units, still the same amount she's used, 2,400. This time we're going to be multiplying by 11.32 pence. 0.1132. Which is £271.68. So the annual bill with domestic will be £271.68 plus the standing charge, which equals £271.68 plus £57.74 equals £329.42. So she's currently with Beeline. She's looking at domestic, and the advice we will give is it's worth her moving because it's going to cost her less. So Mrs. Ridgely should move to domestic because it is cheaper. And then there's a part B. Mrs. Ridgely finds out later on that VAT of 5% is payable on the cost of the standing charge and the units used. Would this affect her decision? You must give a reason for her answer. Well, because it's the same amount, 5%, on both, the difference between the two afterwards is going to be the same. It's not going to make any difference. So it shouldn't affect her decision. So no, and then you need to say something like, as the 5% is applied to both So the difference between the two will still be the same. Question 18. Aaron bought a bike for £600 on the 1st of February 2010. Every year, the value of the bike depreciates by 12% of its value at the start of the year. So in the first year, it's going to go down. It's going to end up less than £600 at the end of the first year because it's going to lose 12% of its value. So in first year, it's going to lose 0.12, 12% of £600, which is £72. So if he bought it on the 1st of February 2010, on the 1st of February 2011, it's worth £600 less £72. So it's worth 528. And then in the second year, it's going to lose another 12% of its value. So if we now look at the second year, it's going to lose 12% of, but not £600 now, £528. So it's going to lose £63.36. So on 1st of Feb 2012, it's going to be worth what it was at the start of the year, less £63.36, which is £464.64. And what you need to do with these questions in particular is read the question carefully, because in this particular instance it's saying find the value of the bike on the 1st of February 2012. So the bike is worth £464.64. Sometimes that question could have asked how much money has the bike lost in the 2 years, in which case you would need to take what it's worth at the end of it away from 600 to find out how much it's lost. So it's really important you read these questions carefully and get your head around what it's asking you for before moving on. And then the final question. Now we did a question just like this when we did topic work on areas of circles and circumferences of circles. So if you don't get this, it's well worth going back and checking that. Okay, so we've got a circular photograph placed in the square frame as shown in the diagram. The diameter of the circular photograph is 8 centimeters. Well, the diameter is the distance all the way across the circle through the center. So if it's got a diameter of 8, that means what I've got here is a square that is 8 centimeters by 8 centimeters. So if that circle wasn't there, I'd have an 8 by 8 centimeter square, which I could find the area of. The area of the square will be 8 times 8, which is 64 centimeters. So if that circle wasn't there, you would see 64 square centimeters of frame. Now the area of that circle, and you need to be able to write this down, okay, it's not given to you, area of a circle is pi r squared, where r is the radius. And if the diameter is 8, the radius is the distance from the center to the circumference of the circle, and that's going to be 4. So the area of the circle is pi times r, which is 4 squared. And you can just type that into your calculator as I've written it. So pi is this, oops, can't see it. Pi is that button there. It's just above the times 10. Okay, so you've got to use the shift button to get at it. So you do shift times 10 to the power of x button, and up comes pi, open bracket, 4 close bracket squared. So I've typed it onto my calculator exactly as I've written it there. Press equals, gives you 16 pi. Turn it into a decimal by pressing the SD button, and you get 50.2. Let's work to 2 decimal places. It's a 6, the next one is a 5, which means that becomes 7. So 50.27 centimeters squared. So what we've got here is a square, which if that circle wasn't on it, you would see 64 centimeters squares of. But the circular photograph covers that much of it, 50.27 square centimeters. So the bit that you can see grey is the difference between these two. So it's going to be 64 less 50.27, which is going to be 13.73 or 13.7 centimeters squared. And that's it. That's the last half of the last pilot paper that we've got access to. Hopefully, if you've gone through all of those and you concentrated on the ones you weren't sure of, and by watching these videos and pausing them, rewinding them, trying them yourself and so on, you've got to grips with those, then you really will have no problems when it comes to the exams in the next few weeks. Remember, you're aiming to get 70 on the paper, and do a little running total if you've got time yourself. See how far in you need to get in order to make that C. If you can get full marks up to question 14, then everything beyond it is a bonus. If you're going to get things wrong in here, then hopefully there are some of the questions beyond question 14 where you're quite confident that you're going to pick up marks. Good luck, folks.